Hi, I'm Rich with insideHPC. We're here at SC16 in Salt Lake City, and today we're at the DDN booth with Laura Shepard. Laura, welcome to Salt Lake City.
Well, thank you very much, Rich. Happy to be here.
All right. Well, thanks for having us at your booth. Can we start at the beginning? Can you tell folks who is DDN and who do you help?
Oh, sure, absolutely. So DDN is a provider of high-performance data management solutions and storage systems. And we help primarily people in traditional high-performance compute areas access and manage their data more quickly. Increasingly, however, our growth is coming from more of the enterprise side. So we're seeing a lot of growth in financial services, manufacturing, oil and gas, and analytics throughout enterprise environments as well.
Okay, so with the explosion of data, that makes sense. Everybody is creating more data, and they need companies like you to help them with that.
Absolutely.
Well, so what are you showing off this week at SC16?
Many, many things. As you can see, we have a lot going on. Well, right now you're standing next to the flash scale. This is our all-flash array, and it's based on our DDN 14K platform, as are many of the systems I'm about to show you. DDN 14K we started shipping about a year ago. It's a very high capability platform. We have full channel support for multiple drives in every enclosure, which means that we can take advantage of new media as it becomes available. And so, for example, here we have SAS SSDs, but then over here we have a version that's running our burst buffer, which is able to address multiple NVMe SSDs. And the burst buffer is a layer that's becoming increasingly important, especially in the high end of high performance computing, where people are finding the limits of their parallel file system, having to deal with POSIX lock contention, getting in the way. We had a customer demonstrating at our user group, they had a 500 gigabyte a second parallel file system, which was getting 5 gigabytes a second because of the amount of contention they were getting from mixed I/O in their environment. But then they put a burst buffer in front of it, and the burst buffer, in this case it's infinite memory engine from DDN, puts a layer of NVMe in between the compute and the storage, which lets you write anywhere indeterminately in the NVMe space, takes account for where all the data is, aligns it at the back end, and then feeds it to the parallel file system in optimum sizes. So you can get the max out of your parallel file system. It also does a couple of other things. It doesn't just take burst loads, but it also allows you to use this level of NVMe as an external computational space for problems that are too big to fit in memory for the compute side. So that's another great use case. And another great use case that people come is kind of a flip side of this I/O optimization I was talking about for the parallel file system is if you have a specific application that's bringing your parallel file system to its knees, that's also a very good indication that a burst buffer would be a good thing. The demo that we're showing live right now is we're showing multiple different I/O patterns writing to the burst buffer at the same performance to give people a kind of an understanding of my application, with 4K strided writes is doing this, blah, blah. Mine is doing that. Both of them are being equally accommodated at the same level of performance in the burst buffer. So that is one thing here, and probably in the middle is where we want to go next, and that's where you're going to see our parallel file system appliances, where we take the DDN 14K platform, we sell it as the SFA 14K, and we're able to run parallel file systems against it with either external metadata or by embedding the parallel file system inside the storage controller to remove a great deal of latency. So let's wander over there and take a look.
Take a look. All right, so what are we looking at here, Laura?
So what we've got here is an ES14K. The E means that this is an embedded Lustre system. And we have Lustre inside the storage controller. So you have multiple drives here. You've got 72 drives in the controller head, 84 in every 4U after that, making this the densest system in the market. The head can run at about 60 gigabytes a second block or 50 gigabytes a second through the parallel file system. So what we're showing here is the ES14K, which is a Lustre embedded in the controller. And then what we've done is we've added several capabilities in Lustre. We've taken some open source capabilities like being able to work with SC Linux, being able to work with Docker for containerization, and we have added our own feature, which is subdirectory mounts, which is something that we developed, and the community is aware of this in Lustre, and that we will be upstreaming as well. And with subdirectory mounts combined with Kerberos, SC Linux, and Docker, you have complete Lustre isolation so that you can present a multi-level security solution on Lustre, and this is new. And another thing that we did is we took the intersections of all of those different components where all of the extra components in security cause you to lose some performance because everything is adding a lot more communication. And we've optimized the communication at all of those different intersections where it was slowing down, so you can go about 2x faster with our optimizations than you can if you didn't have them. So here you have multi-level security 2x faster than you can do it anywhere else. So.
Well, Laura, you know, this being SC16, this is where we talk about hero numbers.
Right.
I understand you have a new top 10 system that has some pretty remarkable data rates.
Yes, absolutely. So Oak Forest Packs, this is a system that's been put up by JCA HPC in Japan. It's a 25 petaflop system, and they are running a 500 gigabyte a second parallel file system, but on top of it, in order to maximize that parallel file system, they're running the burst buffer. So they're running infinite memory engine burst buffer, and they just recorded and published at this show a number of 1.56 terabytes a second file system.
Terabytes with a T.
With a T, absolutely. Yeah. Storage solution is not complete until we've talked about object storage, because everyone is trying to move to having an archive so they can cost reduce their data and also be able to share it in private and hybrid clouds, right? So we have our web object scaler over here. This is our WAS object storage. So DDN's WAS object storage, and we're showing it here. And we have high density solutions. We also have more performance solutions, and we also sell this software only as we do the burst buffer. So the burst buffer or WAS, you can use software only and use it with your own hardware. So that's something that's very exciting to a lot of our customers. And we also have a single view of the data across the burst buffer, the parallel file system, and the object storage. So if your end users, your applications can all see their data regardless of where it physically resides. And if it's on the object storage, it's location agnostic as well. Our object storage, they're pretty much self-aware. It can talk to a node wherever it is. So you can have half your nodes here, half your nodes in Dubai, and it's the same single shared namespace across all of that and your file data. So it has enhanced metadata capabilities as well to make everything very, very searchable. And metadata is, of course, the big important discussion that people are having, as well as performance these days, is how performant can I make it and how quickly can I find it, right? So what we're doing is making the data available regardless of which tier of storage it's on. We're automating the movement of the data between those tiers so that you don't have to have the administrative capabilities to do that. So it's all automated in the system with a single view. And this is something that's unique to DDN, and the active archive component is something that we're really seeing a lot of pickup on.
Well, we can't go away without asking you about security, because I understand you got a new product there. And people ask me, well, what's up with their SC Linux solution? What's the deal?
So this is the one that we were talking about over here. So we're calling it the MLS Luster solution. So this is something where we're going to consult with you beforehand to find out what your security needs are, right? Yeah. But if you fit into a standard security model, basically the concept of I have complete isolation by identified credentials, and I want to make sure that once someone has been identified and let into the system at the appropriate level, they're not able to read up above their security level, and they're not able to write down below their security level. This is a very classic model. If you fit somewhere in this field, then you probably want to be talking to us about a multi-level security solution on Luster.
Well, Laura, it sounds like a terrific, exciting week for you here at SC16, and I want you to have a great show.
Well, thank you so much, Rich, and thanks for coming by.
Oh, my pleasure.